Okay, for this simple electric circuits, problem set 1. Three resistances of 15, 18, and 22 ohms. 15 ohms, 18 ohms, and 22 ohms are connected in parallel. What resistance must be connected in series with this combination? To give a total resistance of 25 ohms. Okay, now we have since the given is under the parallel, we have 1 over R is equal to 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3. Okay, substitute the values. We have 1 over 15 plus 1 over 18. 1 over 18 plus 1 over 22, which is equal to 83 over 495, where R now is equal to 495 divided by 83, which is equal to 5.96 ohms. Okay. Now, what resistance must be connected in series with this combination to give a total resistance of 25 ohms? This is not the final answer. Okay. The requirement is the resistance must be connected with this combination to give a total resistance of 25 ohms. Okay. Let your R prime plus R is equal to 25. Okay, from that equation, we can say that your R prime is equal to 25 minus R, where R prime now is equal to 25 minus 5.96. Okay, where R prime is equal to 19.04 ohms. Okay, this one is the final answer. Okay, for problem set number 2, okay, what is the resistance? What is the resistance between A and B in figure below? Okay, for letter letter A, okay, first draw the figure is we have figure. This one is 9 ohms. This one is 5 ohms. And 8 ohms. Now, for the two resistors in parallel, for the two resistors, in parallel, okay, 5 ohms and 8 ohms, we have 1 over R is equal to 1 over 5 plus 1 over 8 is equal to 13 over 40. Okay, the requirement is the resistors between A and B. Okay, between A and B. Okay. Therefore, R is equal to 40 over 13, which is equal to 3.08 ohms. Then, for the resistors between A and B, therefore, that is after the parallel, this one will become series with the 9 ohms. Therefore, using the formula, you have 9 ohms plus 3.08 ohms. Therefore, the resistors between A and B is equal to 12.08 ohms. Okay. Problem set 3, figure below. Shows the 3 resistors R1, which is equal to 8 ohms, R2 is equal to 12 ohms, and R3 is equal to 20 ohms. In 4 different circuits. For each circuit, find the currents I1, I2, I3 in each, and I3 in each resistor. Find also find the current I in the battery. Also find the current I in the battery. For letter A, the given figure is this one. we have the voltage, which is equal to 3.0 volt. Then we have R1, R2, and R3. Okay, for the values of R1, we have R1 is equal to 8 ohms, R2 is 12 ohms, R3 is equal to 20 ohms. Okay, for the total R, which is equal to, since this one is in series, therefore we have to get the sum. We have R1 plus R2 plus R3, which is equal now to 8 plus 12 plus 20. Where R now is equal to 40 ohms. Okay. For IY, since this one is series, the current are all equal. Okay, you have your I1 is equal to I2, which is also equal to I3. Okay, and that is equal now to 3.0 volt over 40. Okay, where I1 is equal to I2, which is equal to I3, is equal to 0.075 amperes. Okay. Okay. Since this one is under the series, of course, your I, the current in the battery is also the same as your I1, I2, and I3. I now for the current for the battery is also equal to 0.075 amperes. Okay. Remember that the formula for the current is equal to voltage over the resistance. Okay, this one is for figure A. Then we have figure B. Okay, for figure B, okay, this one is the voltage, which is equal to 3.0 volt. Then this one is your R1, R2, and R3. Now for the solution, we have your since this one is parallel, of course, your current is not equal with I1, I2, and I3. Okay. Your I1 now is equal to voltage over R1, where the voltage is equal to 3.0 volt over R1, which is R1 is 8 ohms. Okay. R1 is equal to 8 ohms. R2 is equal to 12 ohms. And R3 is equal to 20 ohms. Okay, R1 is 8 ohms. Okay, therefore, I1 is equal now to 0.38 ampere. Now for I2, okay, for I2, that is equal to over R2, which is equal to 3 over 12. 3 volt, 12 ohms. Okay, I2 is equal now to 0.25 ampere. Okay, for I3, we have 3.0 volt over 20 ohms. I3 is equal to 0.15 ampere. Okay, for I4, we have I total is no enter. Okay. Now for I, okay, since this one is under the parallel, where I now is equal to I1 plus I2 plus I3, which is equal to 0.38 ampere plus 0.25 ampere plus 0.15 ampere. Okay, where I now is equal to 0.78 ampere. For letter C, Venn figure, is equal to 3.0 volt. You have your R1, R2, then R3. Okay, again, for R1, we have R1 is 8 ohms, R2 is 12 ohms, R3 is equal to 20 ohms. Okay, this one is series. Then after that, your R3 is parallel. Okay, we have I3, which is equal to voltage over R3, which is equal to 3.0 volt divided by 20 ohms. I3 is equal to 0.15 ampere. Okay. While for I1 and I2, the current is equal since this one is under the series. Okay. I1 is equal to I2, which is equal to electron volt over, since series, you have R1 plus R2. Okay, where I1, which is equal to I2, is equal to 3.0 volt over R1 is 8 ohms plus 12 ohms, where I1 is equal to I2, which is equal to 0.15 ampere. Now, for the current at the battery, we have I is equal to I1 plus I3. Since your I1 and I2 are equal, because this one is under the series, therefore we're going to use only your either I1 or I3. We have 0.15 ampere plus 0.15 ampere, where I is equal to 0.3 ampere. Okay, now for letter D, given figure, this one is R1, R2, R3. The voltage is equal to 3.0 volt. R1 is equal to 8 ohms. R2 is equal to 12 ohms. R3 is equal to 20 ohms. Now, okay, first, look for the total resistance of R1 and R2 and R3. R2 and R3. This one is under the parallel. Okay, let 1 over R prime is equal to 1 over R2 plus 1 over R3, which is equal to 1 over 12 plus 1 over 20, which is equal to 2 over 15. While R prime now is equal to 15 over 2, which is equal to 7.5 ohms. Okay. Now for the current for I1, that which is equal to the current of your I1 for the resistor 1, okay, is the same as the current at the battery. Therefore, your I1 is equal to I, which is equal to voltage over R1 plus R prime, which is equal to 3.0 volt over 8 plus 7.5. Okay. I1, which is also equal to the current of the battery, is equal to 0.194 ampere. Okay. For I2 now, we have I2 is equal to V2, let's symbol V2 over R2. But your V2 is equal to voltage minus I1 R1 over R2, which is equal to 3 minus 0.194 times R1, which is 8 over 12 ohms. Okay, therefore, this one, your I2 now is equal to 0.12 ampere. For I3 is equal to I minus I2, which is equal to 0.194 minus 0.12, where I3 is equal to 0.073 ampere. Final answer. Okay, this one is the value for the current at 1, and then the current for the battery, which is 0.194 ampere, and for I2, that is 0.12 ampere. For I3 is 0.073 ampere.